universalautomation.org. It's about sharing a technology, a shared runtime execution engine.
We call it a game change in the automation because we have first one technology which is based on the IEC 61499, which is the standard which aims at decoupling hardware and software.
Hardware itself is becoming very, very performant in terms of processing and CPU power, and the future is more and more about software.
This approach is really a winning approach because it's very, very flexible. You develop the application once and you can reuse in each different configuration.
That's exactly what Universal Automation and 61499 enables, because it brings a new formalism for developing software, which is object-oriented in nature, and which allows deployment of a distributed hardware for the actual final control system. So let's say that it's a marriage made in heaven.
So if I want to make more conscious decisions based on my business data, which also come from the automation level, I need universal automation to get this data in an efficient way and with the right engineering efforts on the level when I can do and run the analytics.
Offers are available, not just from Schneider Electric with EcoStruxure Automation Expert, but also from Advantech, from Stahl, from ESA in Italy, and from other companies.
Advantech is growing really, really fast. And I believe if you want to keep on growing in the next future, you need to be able to innovate. And when I see universal automation approach, it is exactly the way of innovation we need to go with.
Most of our customers from process automation are pretty conservative, so never change a running system. But now we see a new generation coming up, what is used to new technologies, and they are open to test, to try these new functionalities. And I think most of them pretty well understand the advantages on this. I'm doing this now for 20 years, and I think over the years, this is the most exciting changes.
And from my experience, I see that in the IT, for example, there has been a big revolution. And I expect the same in automation. I don't know when it will happen. Probably it takes a little bit of time, but probably a revolution will come.
Hi, and welcome to this new session of UAO Goes Live. I'm happy to have you today and to have a new session together with the company and one of our members, which is called JNW. JNW will tell us a bit more about one implementation that they did, about the project, including the technology of universalautomation.org based on the IEC 61499 standard, together with a company called DeNora Systems. So let me introduce on the stage Federico. Federico.
Hello, Greg.
Hi, Federico.
Hello,
Can you please introduce yourself shortly and JNW?
Yes, of course. We are a small company. We are a system integrator, and we develop a software solution with the IEC 1499 standard. We work for UAO and a lot of different customers, such as, for example, DeNora, where we developed interesting applications in control, in process control application.
So, can you please tell us a bit more about this this project that you have done?
Yes, basically we developed a solution to implement two processes: electrochlorination and water electrolysis, two very important processes for this industry. And we controlled this small plant through the benefits and the advantages that the IEC 61499 offers to us as developers, and also to DeNora as an user.
Great. I think you have a presentation for us. Let me put it on the stage.
Yeah.
Great. So, yeah, go ahead. Tell us a bit more about your implementation.
Of course. So, just a few words about who we are as a JNW. We started in the 2018 as an innovative startup. We have our own line of product that we are developing and that we work on. But in parallel, as you can see from this slide, we did a lot of projects in 61499 integration, from the TVDA project with Schneider Electric, where we developed logistic application, both in a digital twin way and also in the real equipment. And we work for DeNora. We joined Universal Automation last year. We worked with Green, that is part of the organization. Recently, we started also working on this different kind of process control application. For example, the JES plant project in Italy, where we control hydrogen battery production. And finally, in this year, we are also controlling in our own TVDA demonstrator, the real logistic line, also the Schneider Cobot, using again the same standard and the same paradigm of programming approach. Well, here some words about some of our projects. In Green, we developed an application according to what we call advanced programming guidelines. This was our first experience with these very useful and complex guidelines that we also discuss about during UAO training and other activities we carry on. And as I was telling you, in a JES project, we are controlling another kind of plant where where they are producing hydrogen batteries. These are their test benches, and we are controlling everything with a lot of PLC, Schneider PLCs, and we are controlling everything with the 1499 standard. Again, the TVDA solution, as you can see here, we started with a digital twin line, simulating and communicating from the control, from EIE part to the digital twin of the line. And recently, here you can see in this picture also the real field equipment, the real conveyors, and the cobot. Then we are introducing now. I'm introducing now the Nora project, and this is a very important customer for us. Our work with them started in 2022, and we started developing control solutions for electrolytic cells. Okay, now we are controlling more than 80 cells in their laboratory, and one important aspect of this work is that we are also facing complex IT/OT architecture, and the focus of this application is the collecting of important data from the field and from the process. And so even in this first experience with DeNora, we face it one of the key concepts and one of the most important advantages of this methodology and of this standard of automation. First of all, the event-driven architecture that fits perfectly to this kind of application, where we have a process to control, okay? And the modularity. In fact, as I told you, we developed the control solution for electrolytic cell, okay? And here in the slide, you can see a typical object of EIE, a cut, where we encapsulated the key logics, the core logics of a single cell, and then we were able to reuse it, make it reusable in a lot of different situations, implementing, for example, a single process with 30 cells, for example, all communicating with each other and controlling the field equipment. So the scalability is also a very important advantage that took place in this application. We tested also the independence from the hardware, as we saw in the introduction video. It is one of the core of UAO and of this standard. In fact, we were able to deploy the solution and the logics in both physical PLCs, the DPAC controller from Schneider, but also on the soft DPAC. So theoretically, it can run in Windows or Linux machine or whatever you prefer. you can use industrial PC or the hardware that you need, that you have available. So we easily distributed the code on multiple resources. That was very easy using EIE and using our application. And we were able also to guarantee flexible interoperability between objects. We create the communication between different PLCs, different soft debuggs, and also other workstation, maybe that just have to collect data, for example. So this was the final architecture we made up with them. We were able to collect data through Modbus and OPC-UA and OPC-UA. In other workstation, we have databases collecting all this data, and then we also gather this digitalization step with them. But now I wanted to spend a few words about DeNora and this customer of ours. They had basically three business areas. They produce electrodes, and they are a global leader in this kind of industry. They also manage the water technologies, so they provide a solution for water treatment and disinfection. And they also work with the energy transition. As I told you, they are interested into the production of hydrogen. That is a very important topic in these days. These are their numbers, so their global presence. They are in Milan, but they are very big. They are a huge company distributed all over the world with offices, with office R&D centers, and so on. And as you can see, also a very important revenue and income. So now let's face a bit about, let's concentrate a bit about the project we want to talk about today. It was just a typical process control project. As I told you, we had to control both electrochlorination and water electrolysis. This has been done with two approaches. We managed sequence control. Okay, it is a typical topic of process industry where you face a procedural control or sequence or whatever you want to call them, and also closed loop controls. Another important task to do was to collect the data from the sensor and do dashboarding and data analysis. Okay, here's some project inside. The end user is actually another customer of DeNora, located in Saudi Arabia. It is a very huge and very important company for that country. The business area is now the hydrogen production, and yeah, we just completed partially our commissioning in Italy, and we are waiting for the plant to be shipped in Arabia, where we will complete all the operation. But now let's concentrate a bit on the project steps we face, and that actually we always do when we implement this kind of project. First of all, we get the specification from the customer. We want to have P&I, process logics, the information about alarms, interlocks, IO list, electrical diagram. We want to know the equipment list we have to use, and the network topology. The second step we do is the plant modeling. So before we start with the code implementation, it's very important to organize your application, your work, and this document that you produce. So basically, you organize your cause-effect relationship of interlock or alarms. You model your functional behaviors of your application. You schematize your graphs and then your diagram. This is the base to start with the code implementation, where finally you create your logics, HMI, hardware configuration, and the communication between the OT and the IT world, finally. And then, in the end, you, of course, do your final commissioning on the field. So here, I wanted to show you a bit of the PNID and of the process that we received from them. So we have this electrochlorination section and the water electrolysis. In both cases, we have this at the center, we have this cell. We have to control through rectifiers, actually. Here is an example of what we do during the plant modeling. We create documentation, so this cause-effect matrix. And remember, we started also doing this in green plant work, where we organize all the causes and the effect of the plant. These are some of the sensors we had to use, and where we collect data from: flow meters, pH meters, temperature transmitter, oxygen analyzers, pressure transmitters, level switch. So a lot of different stuff involved into the process. But also we have to control stuff. So transformer, rectifiers, variable speed pumps, solenoid valves, heaters. So this is the object we control through sequence and also closed loop controls. This was the topology we built. So we had an M580 DPAC PLC from Schneider Electric, controlling, of course, the logic of the process, communicating with both field HMI, also a remote office HMI. And through OPC-UA, we exposed all the data and saved them into our own Willy collector. And it is the database we use and the system we created as a JNW, running on this Linux mini PC in the network. So let's focus now on the functional behaviors we developed in this application. So the closed loop controls, for example, PID loops, hysteresis loops, and so on. We first received the description, so maintain a certain temperature set point in anode and cathode part of the electrolytic cell. We developed the cut, the PID control cut, and also the algorithm in this basic function block, and we were able to reuse it also in other closed loop of the application. We developed also for each cut, for each object, the HMI and the symbol, the graphic symbol part. You can see here also the makeup concentration control. Again, we use the same object. You can see here the reusable, the concept of the modularity of the standard. We control the ORP value, regulating pump flow rate, using again the same PID controller. And we develop also pH control. Okay, this time not using the PID loop, but a classical hysteresis algorithm where you switch on and off the pump to maintain the target value, basically. And we also did some very simple level control of different tanks. This is an example, D201. We use the digital level switches to maintain always the same level of flow of liquid inside these tanks. And then maybe the most difficult part of the implementation. So when you face sequences, okay, you have to manage a lot of different steps. Maybe a bit complicated state machine where you have to stop, start, abort the sequence, or take this kind of decision. Again, you can see on the left side, we developed the cell cut and the rectifier cut. So basically for all the functional behavior and the subsystem we model for the plant, we used this kind of object. And here, managing and monitoring the toroidal current meters, we were able to control the rectifier. Okay. We also implemented tank filling sequences. So basically, according to the reading of these level switches, we had to insert in the tank different kind of reactive flows, maybe urea or just simple water or other kind of liquid useful for the process. And we had to complete this sequence according to what the customer gave us. So basically, we build with him the graph set, so the diagram, And here you can see the translation into EIE. So in this basic function block, we build the state machine able to control the tank filling sequence we had to implement. Then, when we created our software architecture, we followed in a light way the UAO advanced guidelines I mentioned at the beginning. So basically, we organize all the software object, all the cut of the solution in the same way. So we have always this kind of frame organization where we communicate with the field. We have the field input interface on the left side, and also the software, the functional input interface, where we receive signals from other cut or from other areas of the software. We have the logic part, the field output interface, of course, and the internal initialization. We organize it this way. You can see on the left side the electrochlorination further cut, containing all the functional behaviors you saw previously. You see here there is another representation, but you can see on the left side in the field input interface we communicate with analog input cut, digital input cut, and of course again these are reusable objects for our implementation. The D200, the D104, the cell, the pH control, the makeup concentration control, all these functional behaviors are encapsulated inside this electrochlorination cut. And on the right side, we control digital or analog device, for example, variable speed pumps, variable position valves, and so on. We did the same with water electrolysis section, of course, but controlling different functional behaviors. And an important aspect is that using every time cut, you can build already there your symbol and your graphic representation of your object. This way, it is very easy, finally, to build a representation of the original PNID. So basically, we developed the graphic symbol for the pump, for example, and now we are using it in the global PNID. Same has been done with the tank, with the level switches, with all this kind of field equipment. And you can see here a representation of the original PNID. And on the right side, of course, all the command and the parameters that the operator has to set to properly control the process. We did the same with the water electrolysis, of course. And as I told you, the last step of the code implementation was the communication between the OT and the IT world. Basically, we collected in one single cut all the sensor, and you can see here about 15 variables that we were monitoring from the field, and then we easily exposed them through OPC-UA from a single node, single cut, and then we were able to collect them in an external database and show them in Grafana or other system that allows you to print data in a graphical way. So let's summarize a bit what are the benefits we face during the implementation of this solution. Of course, the modularity. Okay, so we organize the code in well-defined functional blocks. Okay, and in this way we simply reuse them where we need them. And yeah, this is very important because when we create an object for one project, it is possible that we reuse it also for other projects, not only in DeNora, but also for other customers. As soon as you develop your own analog input, your own digital device cut, your own rectifier, you can easily reuse it. Okay, and as I told you, also the HMI symbol are always the same. The frame organization of the advanced guidelines is very useful for code readability and cleanness. Okay, as soon as we want to do some small modification, or we want to debug some strange behaviors during the commissioning, we immediately know where to go to find this information, to debug, to find the problem. Okay, so this is very, very useful and important. Also the maintainability and the facilitated improvement. Okay, because you splitted your big problem in small semi-independent object, and you can easily make a modification there, avoiding the risk to propagate errors or unexpected behaviors around the code, around the process. So organizing this way your work is useful for this kind of topic. And here also another advantage we face is that internally in our company we were able to work on more hands on the same solution, and it's not an easy topic because this time we were able, for example, in just 2 persons to work on different functional behaviors. My colleague developed the rectifier cut, I developed the cell temperature control, and so on. These are examples. And then finally, one single developer can simply integrate everything in the solution, okay, and make the communication is really fast because you create the interface of your cut always in the same way. So basically, this was our approach to this process control application, and the advantages we faced during the code implementation.
Great, thank you, Federico, for this this introduction and presentation. Just a few questions which are coming out of my mind. If so, when you saw that project with DeNora, what made you select like this technology, so 64099, to implement your solution over, let's say, other traditional code like 61131 and so on? Why did you choose this technology in particular?
Yeah, basically, I would say the event-driven approach is the most important aspect, and it fits perfectly to this kind of process control industries where basically you don't need to run a huge code following a time cycle, let me say, a timer of the PLC, but as soon as something happens in a specific place of the plant, then this event is collected and something else has to happen. So this kind of organization fits perfectly with this standard, I would say. And also all the advantages I mentioned are perfectly done with this technology, I would say. It's very easy to organize your code, to encapsulate your problem, to divide it into different small functional behaviors and a small problem. So the object-oriented, I would say, approach is very easily done in this way.
Thank you for the feedback, and for sure we can see in the way that you let's say created your program, that you organized it, that there is behind like thinking or method how to best utilize the or to make your program more efficient using 64099 with on one side the logic, on the other side the interface with the I/O. Then all those are really, let's say, separated and well constructed. I would like to remind to our viewers that if they have any question, please just type your question in LinkedIn or YouTube, and then we can see it and ask it to Federico. Maybe another question from my side, Federico, which is like more linked to let's say the portability of the code. So today we saw in your presentation that you were using I think the M580, and you were using the Softipack, so kind of containerized version of the runtime, which could run on any Windows or on Linux or server architecture. From your experience, how much time, like roundabout, would it take for you to like change the targeted hardware? So let's say use another hardware which still embeds the UAO runtime for sure, but in terms of code change, in terms of let's say change in the code, how much time would it take for you to like change the targeted hardware?
Yeah, maybe it's difficult to tell you how long will it take to me, but I would say that the portability of the code is a very important advantage offered from the 61499 and from the standard and from this technology. Basically, if we are using the UAO runtime, I would keep the code identical, just maybe change some configuration in the network topology, in the hardware configuration. Of course, something you have to do, but basically the logic, the implementation of the code is ready as soon as you finished it. And you can easily deploy on another resource, and the work you've already done with the debugging and testing is always valid, I would say. So it's very quick, probably.
Yeah, it's it's a value that we always push forward. I mean, as Universal Automation Network, we speak about the decoupling of hardware and software, and it's always interesting to see it from the, let's say, from the field, that what we actually say is not only, let's say, marketing, let's say a marketing slogan, but it's actually what is actually used on the field. And another question, because you are a system integrator, and what made you a system integrator decide to join the organization universalautomation.org?
Yeah, basically, I would say that we strongly believe in the standard and in this technology and in this automation approach. We believe that this is the future, and we really we liked it, and we think that is an advantage for us implementing this way and working with this technology. And we every time we try to push it and also propose it to our customers, telling them that it is what they need, basically, and we are comfortable with it. We know it, and and there are also other aspects, and this is also an occasion to share ideas inside the organization. We can do a lot of networking and find opportunities and see what's growing, what is happening in this direction, I would say. So
yeah, I mean, for system integrators, finding opportunities as well through the organization, for sure, that's a big point. We see, for example, collaborations that you work with Geoffrian, which is one of our member. We had in one of the last live, we have the company Barbara working on orchestration and high scale deployment of the runtime, as well working with other members. We have had as well some other system integrators. I can recall, for example, company Platinum or Twice System as well, showing how they use the technology. And would you have let's say a word, or would you have if you would have to like tell to other SI to join the organization, what would you tell them? How would you encourage them to join the organization?
Very difficult question, Greg. A marketing question. No, well, I would say that probably the best way is to show all the different things we are doing as an organization, and all the different companies that are joining it can say something different. So there is a kind of heterogeneous nature behind it. So where you have also a big company have the same space of a small company, because we are working for the same aim, for the same objective. And I think this is a very healthy and good environment to work in the world of and in the field of automation. That it's not always easy to work with in the real application, the real industry's world, I would say. So this is my opinion.
Okay, good. Thanks, Federico. Now I see that there was one question coming from LinkedIn from Augustin Fragosoleon. How can you guarantee no event is lost within the application to ensure that the required piece of code is executed?
I would say that the answer stays into the runtime code. So probably this is a more technical question for someone more expert than me. But regarding the implementation, this is very easy. So basically, you link your event, okay, to the from the source to the final destination in the code. So from one cut to another, but also from other kind of blocks that you usually use inside your application. And then when you make your event travel together with its variables, you are pretty sure that everything will work. I never faced problems regarding the risk that an event doesn't go in the destination. So basically, you are totally sure about that.
Yeah, thank you, Federico, for coming to that. And what I could add to that. So for sure, this could be an interesting topic for one of the next live with our chief architect officer, who could tell us more about the mechanics behind how the events are, let's say, ensured between blocks from the runtime perspective. Yeah. But as well from the use cases that we see, we have had one of the big use cases is the one we have had in Baton Rouge from the company ExxonMobil, together implementing, let's say, the OPAF standard and using as well the UAO technology behind, with quite huge scale implementation. So those are quite good, quite nice implementation. Your implementation as well, what you did with DeNora is as well. How many? Do you know how many IOs are we speaking about here in that project?
In this project, probably not so many, because it is a small plant, like the first one they are developing for the final end user in Saudi Arabia. Okay. But I would say that totally with the Nora in the laboratory, we are speaking about thousands of IO, probably.
Yeah,
so
thousands of IO.
Not so small.
And so far with the test done, no issues about let's say lost events so far.
No issues about that.
So that's quite a proven technology.
Yes,
good.
Of course.
I don't see any other question coming from the chat, so I think we are quite good. Federico, here are the contact details if you want to contact Federico for any other inquiries or any other project. Let me mention as well that Federico is one of our trainer for the advanced programming on 6.99. So like all the methodology behind 6.99, how to best execute, how to best design your program actually, and all the methodology that you have shown in your slides, those are actually part of the training, and this training is offered as well when you become a UAO member. So that's a good point to mention. And I will take now the opportunity to thank everyone, thank the viewer for coming here, and thank you, Federico, for making it with us today. It was quite interesting feedback from you and share of experience about 6.99 at DeNora. So thank you again, Federico. And see you soon.
See you soon.
Thank you all. See you. Bye-bye.
Bye-bye.